Okay. So, all right. So, we discussed in our last lecture the differentiability of an atlas. The question arises, why are we talking about the differentiability of an atlas or maximal atlas, etc.? The basic issue is we want to discuss differentiable functions of manifold. And in order to define a idea of a differentiable function, we need to equip the manifold within a structure which could help us in defining these differentiable functions. So, as usual, I will be denoting by M an n-dimensional manifolds. So, this is a manifold of dimension n, and I will assume it's a differentiable manifold. When I say it's a differentiable manifold, means it has a maximal atlas, which is a differentiable atlas. So, I am assuming that M is a differentiable manifold. Let me clarify, even if it does not have a maximal atlas, it has some atlas A which is differentiable, still I can talk of differentiable mappings. Okay. So, for a moment, let me consider a manifold which is not differentiable, but it has an atlas A which is a differentiable atlas. Suppose this is a differentiable atlas on M. Okay. So, means it has charts which cover the manifold, and on the intersection part of the charts, the transition maps are differentiable. So, situation is like this: you have a manifold which has an atlas, so around every point you have an open set which is homeomorphic to an open set in Rn. So, if it is some u alpha, then this is phi alpha, and an open set phi alpha un is sitting in the space Rn. Now, consider a real valued function. To begin with, I will be considering some real valued function f from manifold to R. Okay. Now, look here, whenever you have a function from manifold to R, I will be getting this map f composition phi alpha inverse from this open set, from such open sets into R. So, for a moment, let me forget about the manifold and just look at the map and ask myself whether this function is differentiable in the usual sense. If you have a map from open set of Rn into R, then the differentiable function makes sense. We call them Euclidean differentiable. We have discussed the calculus of such function. So, the formal definition of differentiable function is f is said to be differentiable at a point P. The point P will be contained into some neighborhood u alpha. Suppose it is contained into u alpha. I will say f is differentiable at P if this map is differentiable at phi alpha P. So, phi alpha P will be somewhere here. So, let me write down the definition. F from manifold to R is said to be differentiable at a point P if P belongs to M, of course, if P belongs to u alpha, some open u alpha phi alpha, a chart u alpha phi alpha, such that f composition phi alpha inverse from phi alpha u alpha into R is differentiable at phi alpha p. देखिए मैंने दोनों जगह लिखा, इसको भी डिफरेंशिएबल कह रहा हूँ और इस मैप को भी डिफरेंशिएबल कह रहा हूँ। दोनों में फ़र्क ज़रा सा ये है कि ये डिफरेंशिएबिलिटी इन द यूजुअल सेंस ऑफ डिफरेंशिएबिलिटी ऑफ आर एन. So we should call it Euclidean differentiable. I should better write down Euclidean differentiable.
Terminology is different means.
हाँ ये मैं बताता हूँ अभी. Euclidean differentiable at phi alpha p. देखिए बात समझिए, इस फंक्शन की डिफरेंशिएबिलिटी का इससे पहले कोई मतलब ही नहीं होता था, क्योंकि मैनीफोल्ड तो टोपोलॉजिकल स्पेस है, वहाँ पे फंक्शन की डिफरेंशिएबिलिटी के कोई मायने नहीं है. फॉर द फर्स्ट टाइम वी आर टॉकिंग ऑफ डिफरेंशिएबिलिटी ऑफ फंक्शंस ओवर ए मैनीफोल्ड एट ए पॉइंट ऑफ कोर्स. तो उसे हम डिफाइन करने के लिए किसी नॉन डिफरेंशिएबिलिटी को यूज़ कर रहे हैं. कौन सी नॉन डिफरेंशिएबिलिटी है यहाँ पे? दिस इज द डिफरेंशिएबिलिटी दैट वी नो, because it's a map from an open set of Rn into R, and we understand the meaning of differentiability of maps from Rn to R. उस differentiability को वजाहत करने के लिए मैं अब यूक्लिडियन डिफरेंशिएबल कहने लगा, ठीक है, लेकिन फ़र्क वाज़ेह होना चाहिए. So I am defining the differentiability of f in terms of the non differentiability of f composition phi alpha inverse. ठीक है. दूसरा रिमार्क, we have stopped talking about CR functions because we have realized in our earlier lectures that whenever you have a differentiable atlas, it is always contained into an atlas of class C infinity. Is it right? If you have an atlas of class CR, it is contained into an atlas of class C infinity. So forget about CR differentiability. All the time we talk of simple C infinity differentiability. Alright. अब ज़रा गौर कीजिए इस definition पे, और now you will see that this definition seems to be depending on the chart containing the point P. Apparently it looks that our differentiability depends on the chart. It looks as if I change the chart, because P will be contained into other neighborhood also, the differentiability may be lost, but actually it is not. If your atlas is differentiable and the function is differentiable with respect to one chart, it will be differentiable with respect to every other chart containing the point P. Okay, so this you note down.
It's the result, sir.
It is, no, I will prove it. It's a result, but one can easily understand this fact. So the above definition of differentiability of a function, above definition of differentiability of a function is independent of of the local chart containing P. Containing the point P. हमने डिफरेंशिएबिलिटी एट ए पॉइंट फ़िलहाल डिफ़ाइन की है, तो ये पॉइंट जो है वो किसी और नेबरहुड में भी जा सकता है, और फिर यहाँ फाई अल्फ़ा इन्वर्स की बजाय कोई फाई बीटा इन्वर्स या कुछ हो जाएगा, तो फिर अब पता नहीं वहाँ क्या मामला होगा, लेकिन कीप इन माइंड दैट एटलस ए इज़ डिफरेंशिएबल. यू विल अंडरस्टैंड दिस रिमार्क in a minute. Look here, suppose P is also contained into some u beta phi beta. Okay.
Yes, sir.
Then this u beta phi beta will take it into Rn somewhere over here. This is phi beta of u beta. Intersection part, let me shade. So this map I know from the definition of differentiability of an atlas. It is phi beta composition, phi alpha inverse. Okay. Now to check whether my function f is differentiable with respect to this chart. So in order to see this, I will compute f composition phi beta inverse. अगर किसी फंक्शन की डिफरेंशियबिलिटी आपने देखनी है तो ये डेफिनेशन कहती है कि f कंपोजिशन फाई अल्फा इनवर्स चेक करो कि ये फाई अल्फा पी पे डिफरेंशियबल है या नहीं. हाँ, यूक्लिडियन डिफरेंशियबल है कि नहीं. सो आई विल सी इट एंड लुक हियर, f composition phi beta inverse I can write down as f composition phi alpha inverse composition phi alpha composition phi beta inverse. This map will be phi alpha composition phi beta inverse. ठीक है ना. अब आप यहाँ से अगर यहाँ की मैप देखें तो this map can be written as this composition, this. Now look here, this map, it's already differentiable with respect to u alpha phi alpha inverse, and this map is differentiable because our atlas is differentiable, and therefore their composition will be differentiable. All right, in the usual sense. Okay, so this implies our function f is differentiable with respect to any other chart u beta phi beta containing the point p. Okay, so जो बात apparently महसूस हो रही थी कि शायद ये differentiable ना हो, वो नहीं है. In fact, if it is differentiable with respect to one chart, it will be differentiable with respect to every other chart containing the point p.
So whenever you want to do something on the manifold, because we know very well about Rn, so we always take the image of P to Rn and then take inverse image.
Yes, yes,
Like
but
we are doing something with P and then taking back it.
Yes, but this process is done only locally.
Locally.
Locally, but globally, if you want to do manifold, these techniques will not work. So अभी differentiability at a point define की है. So now let me add one more thing, a function f. When I say function, I mean real valued function. A real valued function.
So in the definition we say that manifold is a locally Euclidean space. So sir, can't we say because locally it is Euclidean, so locally it will be having all the properties of Euclidean space?
No. It doesn't happen. All local properties are not carried because differentiability doesn't carry. For example, a piece of a sphere, if you look at it, it is curved. But whereas a piece of R2 is flat, so curvature do not carried away. It is preserved under diffeomorphism only. So everything doesn't go. Okay?
We have to verify it, sir.
Yes, a real valued function f from U is an open set in manifold M. Manifold is denoted by capital M, which is assumed to be differentiable. Is said to be differentiable. A real valued function is said to be differentiable on U, is said to be differentiable on U if it is differentiable, yes, at every point of U, at every point of U. So we can talk of differentiable functions on open set of manifold as well. So this is the meaning. Now still there is one problem. Now our definition is definitely depending on the atlas. Okay. If I have another atlas on the manifold M, say B, then a function may be differentiable with respect to atlas A, but may not be differentiable with respect to B. But this is something which you will not like.
But this will happen only when they are not compatible.
Suppose A and B are not compatible, then if A is differentiable with respect to A, it may not be differentiable with respect to B. Okay, so what I will be doing, that is why we talked about maximal atlas. We will consider the union of A and B. Okay, so if you club all the compatible atlases together, then you will not care about a particular atlas. Okay, so this is an important note. If a function f when I say function, I always mean a real valued function. If a function f is differentiable with respect to one atlas, it may not be differentiable. It may not be differentiable with respect to another atlas. So to avoid this difficulty of dependence on a particular atlas, we will be taking together all the atlases together. So to avoid this difficulty, we club all the compatible atlases. All the compatible atlases together. So that if a function, so that the dependence is removed. So this union of all compatible atlases, as you observed in our last lecture, is called the maximal atlas. So to talk about differentiability of a function, I will be assuming that a manifold is endowed with a maximal atlas or a differential structure. Okay, so this atlas is the maximal atlas. This atlas is the maximal atlas. And that is why this maximality is important. Okay? All right.
So it means we are saying a function is differentiable, it means we are talking about
we are taking a maximal atlas. तो फिर ये हमें कहने की ज़रूरत नहीं रहेगी कि भाई ये फंक्शन फला एटलस के रिस्पेक्ट में डिफरेंशिएबल है. फिर कोई दूसरा ला के खड़ा कर दे तो वो प्रॉब्लम हो जाएगी. इसलिए व्हेन वी टॉक ऑफ डिफरेंशिएबिलिटी, आवर एटलस इज मैक्सिमल. All right. Now we must have some examples of differentiable functions on a manifold. So one easy observation You know that if you have a manifold, then around every coordinate neighborhood U alpha, this homeomorphism phi alpha give rise a coordinate system. What you do in order to get hold of coordinates, you just compose it with UIs. UIs are slot functions on Rn. This is inside Rn. So these slot functions are available as functions from Rn to R. By composing these two, you get UI composition phi alpha. And this real valued function on U alpha, usually it is denoted by X alpha I. Okay. So X alpha i's are in fact real valued functions on U alpha. So I can ask myself whether this real valued function on U alpha is a differentiable function. I am assuming throughout that atlas is maximal and differentiable. Okay. So the question is that X alpha I for each alpha is differentiable or not. The answer is yes. A coordinate function, so my claim is a coordinate function, or in fact all coordinate functions. So coordinate functions on a coordinate neighborhood are differentiable functions. This comes as a first example. And why it is so? Now to check whether a given function, so I pick one X alpha I. So this is a map from U alpha to R. You can see from the example. How would you check whether it is differentiable or not? Look at the definition. In fact, so to check that whether it is differentiable or not, by definition, I will check X alpha I composition phi alpha inverse. Okay? If this map turns out to be a Euclidean differentiable function, my answer will be कि yes, X alpha I is a differentiable function on U alpha. So you should check what it is. देखिए X alpha I वहाँ से is equal to UI composition phi alpha. यही है ना? अब यहाँ से पता ये चलता है कि X alpha I composition यहीं पे आप इसको कंपोज कर दें phi alpha inverse के साथ. तो ये हो जाएगा, this will become UI composition phi alpha composition phi alpha inverse. So this becomes simply UI. And UI are known functions on Rn. These are slot functions of Rn. They are well behaved functions. They are differentiable. So this is nothing but UI. And UIs are differentiable. As UIs are differentiable functions on Rn, are differentiable functions on Rn, by definition X alpha i's are differentiable functions. Okay. So this gives me the example of a differentiable function. We will talk about some non-trivial example little later. But now this is the first and trivial example. All right. Now next is partial differentiation. So, to compute the derivative of a function is our main aim now. जैसे कि हम आर एन सेटिंग में ये तो जानते हैं कि फंक्शन कब डिफरेंशिएबल होता है, फिर कंप्यूटेशन एक अलग प्रोसेस है, ठीक है, वहाँ पे हम कंप्यूट कर लेते हैं डेरिवेटिव। आर एन में भी डेरिवेटिव कंप्यूट करने के लिए आप जैकोबियन देख लेते हैं क्या है, तो वो दैट गिव्स यू द डेरिवेटिव। मैनीफोल्ड में क्या होगा ये अभी देखना बाकी है, उसी की तैयारी हम कर रहे हैं। सो फर्स्ट ऑफ ऑल आई विल टॉक अबाउट partial differentiation. Partial differentiation with respect to coordinate function. With respect to coordinate functions. Coordinate functions are available on coordinate neighborhoods. So, situation is that you have a manifold M and I want to talk about the partial derivative of a real valued function. Real valued functions are easier to deal with. Okay, suppose f is a real valued function on a differentiable manifold M. This is some coordinate neighborhood u alpha. So P is contained into u alpha. I want to differentiate f at the point P. So it will be somewhere inside u alpha. So inside Rn you will be having an open set phi alpha u alpha. This is the space Rn, and then you will be having automatically the map F composition phi alpha inverse. Phi alpha P will be a point here. What I want to define here is the meaning of del F upon del Xi at a point P. This is what I want to define. Okay? So I will define it like this, as you said earlier. I will look at this function. ये इसको पार्शियली कैसे डिफरेंशिएट किया जाता है वो हम पहले से जानते हैं. This function is a real valued function on an open set of Rn, so I can partially differentiate it with respect to ui's. Ui's are coordinates in Rn. I will take its value at the point phi alpha p. Whatever I will be getting, I will call it a partial derivative of f with respect to xi. So this is my definition of partial derivative of a function from manifold to R evaluated at a point P. Okay. So once you can evaluate it at a point P, you can evaluate at every point of a coordinate neighborhood, and therefore it can be thought of as a function on the manifold once again. Partial derivative of a function is a function as it happens in Rn setting. Now this gives me a relationship between two coordinates. Okay. So now I will give you another situation here. Suppose the point P where I am differentiating a function is inside two neighborhoods. One is u alpha, or you simply call it u, and the other one you call as v. Okay? Or suppose u is homeomorphic to an open set Rn over here. This is phi u. This lies in Rn. Similarly, this would also lie in Rn. सेम Rn है, लेकिन क्लैरिटी के लिए हम दोनों को अलग अलग बनाते हैं. This is psi of v. The map will be what? ये psi है. Psi composition phi inverse. This is the map which you call transition map. यहाँ पे मान लीजिए कोऑर्डिनेट्स हैं आपके एक्साइज, ऐसे आपने अभी देखा कि ऑन ऑल कोऑर्डिनेट नेबरहुड्स यू हैव ए कोऑर्डिनेट सिस्टम। सो वी के भी कोऑर्डिनेट्स होंगे, लेट मी कॉल देम एज वाई आईज, ठीक है। सो माई प्रॉब्लम इज टू सी, जिसका मैं लास्ट टाइम भी जिक्र कर रहा था, I want to see what is del yi upon del xj, ठीक है। ये yi's यहाँ इस शेडेड पोर्शन में अवेलेबल है। यहाँ पे इस शेडेड पोर्शन में xi भी रियल वैल्यूड फंक्शन है और yi's भी रियल वैल्यूड फंक्शन है। तो सपोज मैं xi के साथ काम कर रहा हूँ और yi's को मैं ट्रीट कर रहा हूँ एज ए रियल वैल्यूड फंक्शन डिफाइंड ओवर हियर। ओके, सो आई कैन टॉक ऑफ डेल yi अपॉन डेल xj। तो थोड़ी देर के लिए आप ऐसे समझिए कि yi's आर फंक्शंस फ्रॉम u इंटरसेक्शन v इंटरसेक्शन टू r, और इसको मैं पार्शली इस फार्मूले के साथ डिफरेंशिएट करूँगा, ठीक है ना। सो नाउ आई कैन थिंक ऑफ दिस पार्शियल डेरिवेटिव इवेल्युएटेड समवेयर एट द पॉइंट, किस पॉइंट पे, एट पॉइंट फाई पी, ठीक है ना। p इज समवेयर हियर। तो फार्मूला क्या कहता है, इट विल बी डेल ऑफ yi composition phi inverse xj, and this will be done at the point phi p.
So there should be p, I think.
Huh?
Left hand side it should be at p, no, sir? Not 5p. Sir,
This is the meaning of p, yes.
Yes, sir.
This is p. I'm sorry. Okay, so now what will you do to this? This can be rewritten as and yi. What about yi? Can you understand yi's? Yi's are real valued function. How do you get hold of yi's? yi को देखें तो आप r में ले जाएंगे आपको y by composing through ui. So ui composition psi is yi.
Yes.
So yi, if you understand, will be nothing but ui composition psi. Okay, so replace yi by ui composition psi. No, ये xj नहीं है, ये uj है, क्योंकि this differentiation is happening in Rn.
Yes, sir.
So this is del of yi की जगह I will write down ui composition psi and composition phi inverse is already there. ये composition के जो composition है ये associative होती है, तो मैं ब्रैकेट लगाने की ज़्यादा फिक्र नहीं करता। del upon del uj, ठीक है ना। अब थोड़ी देर के लिए ज़रा गौर कीजिए कि psi कंपोजिशन phi इनवर्स क्या है, वो ये है। इसको अगर मैं थोड़ी देर के लिए f बुलाऊं, कैपिटल F, इट्स ए मैप फ्रॉम Rn to Rn, ठीक है। सो आई हैव del of ui composition f with respect to delta uj done at the point phi p. आप जानते हैं कि जब f को स्लॉट फंक्शन के साथ कंपोज किया जाता है तो ये आपको क्या देता है, ये आपको देता है f का ith कंपोनेंट। सो यू गेट del of fi अपॉन del uj। हाँ, del fi upon del uj, ये f, what is fi? Fi is the ith component of the function capital F, which is in fact the transition map. So del yi upon del xj is defined. this is equal to del of fi upon del uj. अच्छा, ये फंक्शन चूंकि डिफरेंशिएबल है ऑफ क्लास सी इन्फिनिटी, इसका मतलब है एफ के सारे कंपोनेंट्स के पार्शियल डेरिवेटिव एग्जिस्ट करते हैं और कंटिन्यूअस है, सारे ऑर्डर के पार्शियल डेरिवेटिव. दिस मीन्स दिस पार्शियल डेरिवेटिव एग्जिस्ट and they are continuous, and this whatever it is called the derivative of yi's with respect to xj. चूँकि ये सब एग्जिस्ट कर रहे हैं, कंटिन्यूस हैं, ये भी सब एग्जिस्ट कर रहे हैं, ठीक है. सो दैट इज़ व्हाट वी मीन बाय द कोऑर्डिनेट. इसकी बात मैं करने लगा था एक अपने लेक्चर में without really telling you what del upon del xj is. Now the idea will be more clear to you. So now I can revisit to the coordinate transformation. So coordinate transformation is differentiable because these functions are assumed to be differentiable of class C infinity. Okay, so this is the partial differentiation. I will come to total differentiation later, because next thing is to talk about the algebra of functions. Because if you consider the collection of all differentiable functions which are differentiable in a neighborhood of a point, these will form a ring in fact. But if I consider the class of function, they will form an algebra. So I will discuss those things in my next lecture. So I have already taken around 40 minutes or so. I stop at this point.